All right, this video is going to explain what compound interest is, introduce the compound interest formula, show you how to write a function for a scenario involving compound interest, and then how to use that function to solve a problem. So, what is compound interest? Well, compound interest is when you receive a portion of the annual interest at regular intervals throughout the year, allowing you to earn interest on the interest you've already received. So normally in a non-compound interest account, you would only receive the interest at the end of each year. However, in a compound interest account, what you'll do is say it's semi-annual, you would receive interest on your amount at the end of 6 months and then again at the end of the year. Or if it was quarterly, you would receive interest, a portion of the interest every 3 months. Again, this allows you to earn interest on the interest. So the formula for compound interest looks very similar to the ones you were using in the previous tasks, in that you could have the amount at time t, or just y, if you will, is equal to capital P, which is our principal or starting amount, times the quantity 1 plus r, where r is the annual percentage rate expressed as a decimal. That needs to be divided by n, which is the number of compounds per year that's being used for the account. And then that quantity needs to be raised to the n times t power, where t is the number of years the money is being invested. Now, again, the rate, the annual percentage rate, needs to be expressed as a decimal. And the reason we're going to divide that by n is because earlier when I defined compound interest, I said you receive a portion of the interest. And so this is what's going to drive what portion we receive. So for instance, if we're doing it semi-annually, we're going to receive half of it after 6 months, the other half after the year, or at the end of the year. If we're receiving it quarterly, we're going to receive 1/4 of the interest after the first 3 months, another fourth halfway through the year, another fourth 3/4 of the way through the year, and the last fourth of the interest at the end of the year. Now, why do we raise that quantity to the n times t power? Well, since t is the number of years of the investment, we got to think about how many times we're going to receive this lower interest amount or this portion of the interest. So again, like if it's semi-annual and I'm investing it for 10 years, I'm actually going to receive interest 20 times. That is 2 times 10 over the 10-year investment. However, if I'm investing it for 10 years and I'm compounding it quarterly, then I'm going to receive interest 4 times 10 or 40 times over the time of my investment. So that's the formula. Let's take a look at an example. Andrea wants to invest the $1,000 her aunt gave her for her 16th birthday. Andrea's bank has an account where her money will earn 3.2% interest compounded quarterly. Write a function a of t that expresses the amount of money in Andrea's account after t years. All right. So we know we're going to start with a of t because it tells us to write a function a of t. And now we need to identify the principal or the starting amount. Well, Andrea received a gift of $1,000 from her aunt for her 16th birthday. So that's going to be what she's putting into the bank. So that's going to be the principal, that starting amount P. Then the account she has selected is going to receive 3.2% interest annually, but they're going to compound it quarterly for her. So we need to take this 3.2% and write it as a decimal. So that's going to be 0.032. And if you're not sure about that, use a calculator and take 3.2 and divide it by 100. In the formula, though, we're going to divide it by 4 because we're going to apply 1/4 of it each quarter or every 3 months. Now, we don't know how long Andrea is going to invest this, but we do know that for each year she does, she's going to receive the interest 4 times throughout the year. So we'll say 4t. And so we have our function for Andrea's investment. And it'll allow us to calculate, if we know how long Andrea is going to invest it for, how many years, then we can calculate how much should be in our account. So let's assume now, let's use the function. Let's assume if Andrea does not add or withdraw money from the account, how long will it take for her money to double? So we're trying to solve for a time here. All right. We're trying to solve for a time. And so if I do this, and I'm talking about her money doubling, that means in her account, she would have $2,000. Her principal is $1,000. And I'm going to go ahead and evaluate this stuff that's in the parentheses here. So I'm going to come to my calculator and I'm going to say 1 plus 0.032 divided by 4. And I get 1.008. So 1.008. And this is raised to the 4t power. So now we just have an exponential equation. So we're going to solve it like any other exponential equation. We need to isolate the part of the equation where the exponent has a variable in it. So this would be that quantity in the parentheses, 1.008 raised to the 4t power. So that means I'm going to divide both sides by 1,000. So from here, I need to divide both sides by 1,000. That's going to leave us with simply 2 is equal to 1.008 raised to the 4t. Now that I have it isolated, what I'm going to do is rewrite the equation in exponential form. I'm sorry, not exponential form, logarithmic form. It's already in exponential form. And so when I do that, I have to keep in mind where the base is. So I'm going to have log base 1.008 of 2 is equal to 4t. Because remember, the logarithm is always equal to what the exponent was in the exponential form. And now we simply need to solve for t. So I'm going to do that by dividing both sides by 4. Solve for t. And we, again, like I said, we'll divide, to do that, we'll divide both sides by 4. Both sides by 4. So what we end up with then is we're going to have that t is equal to log base 1.008 of 2 divided by 4. Now, I would never go to Andrea and tell her that it's going to take her log base 1.008 of 2 divided by 4 years for her to double her money. So in an application like this is where we're going to go ahead and evaluate this logarithm. So on your calculator, we're going to press mode. We're going to scroll up to option A, log base. We'll enter our base of 1.008. Then we'll enter our argument of 2. And then I need to go ahead and divide that quantity by 4. And so it turns out that if Andrea does not add or withdraw any money from her account, she would need to leave the money there for approximately 21.7 years for her money to double. 21.7 years. That's it.